The way we choose to design the indoor environment can influence human health and well-being. Spaces which incorporate many natural features have been associated with improved mood and cognitive performance as well as decreased stress levels. Wood is a particularly interesting way of bringing nature indoors to create health and well-being benefits. This is because it is a natural and versatile renewable material that can be used structurally, decoratively, and for other functional elements in buildings. A recent study found that spending time in a space furnished with wood furniture led to improved psychological and physiological indicators of stress and well-being when compared to spending time in a matching environment furnished with white furniture. So far, most research on the relationships between wood use and human well-being have focused on human responses to visual aspects of indoor environments or air quality. However, increasing evidence shows that the tactile experience of interior furnishings is important as well. It has been shown that touching wood leads to improved psychophysiological responses compared to touching other common materials such as marble, tile, or steel. However, not much is known about the human response to different types of wood. Our goal is to study how physiological indicators of stress and relaxation vary during both visual and tactile contact with different wooden materials. To get a broader image of human physiological responses, we monitor several indicators. Electrodermal activity tracks changes caused by sweat glands in the skin, which, in turn, indicate activation of the sympathetic branch of the autonomic nervous system. Higher levels of electrodermal activity denote increased physiological arousal, which can indicate higher levels of stress. Stress is reflected in skin in another way, in its temperature. A stress response will reduce skin temperature in the fingers. Another set of useful indicators of stress are measures of the cardiovascular system, such as blood pressure and heart rate. Heart rate variability can be particularly insightful as it can reveal the differing responses of the sympathetic and parasympathetic branches of the autonomic nervous system. Once all electrodes and sensors are safely attached, we can begin our experiment. First, the participant rests for 5 minutes with their eyes closed. This allows the participant to relax and prevents any physiological reactions related to the equipment setup from showing up in the test period data. The rest period also provides a baseline to compare against later. After the rest period, the first material is presented to the participant. The participant is instructed to hold the material with their dominant hand and keep their gaze on the material. After 1 minute of rest, another material is presented. This process repeats until all materials are tested. The physiological responses are then compared between materials. The results help us identify materials that humans react most positively towards. We can then use this information to support evidence-based and user-centered building design that emphasizes occupant well-being. Evidence-based material selection is a crucial step in creating healthy indoor environments for all people.